Welcome to the Verilog Testbench ACP Agent. This is a specialized autonomous coding tool designed to revolutionize hardware design and verification. It leverages the Agent Client Protocol, or ACP, to integrate directly with your development environment. This agent doesn't just write code, it understands hardware constraints. It generates synthesizable Verilog RTL, creates self-checking test benches, and autonomously runs simulations using Icarus Verilog. It closes the loop by analyzing simulation logs and fixing bugs without human intervention, effectively acting as your expert digital pair programmer for FPGA and ASIC design. This tool leverages the Agent Client Protocol, ACP, to bridge large language models with your local hardware tools. How does it work? Look at tools.json. Here, we define specific capabilities like file write, run simulation, and waveform.extract. Through ACP, the agent doesn't just output text, it invokes these registered functions directly on your machine. This transforms the AI from a passive chatbot into an active engineer that can compile code, run simulators, and analyze binary outputs within your secure local environment. We are working inside VS Code, the industry standard editor, utilizing the agent's chat interface. Here, the user provides a high-level intent in plain English. Create a 4-bit synchronous counter with active high reset. This is where Gemini 3 shines. It doesn't just match patterns, it reasons. Gemini 3 analyzes the request to infer implied hardware specifications, determining clock edge sensitivity, reset polarity, and bit width requirements. It then formulates a complete design and verification strategy before a single line of code is written, ensuring the final output is structurally sound and logically correct. Before writing any code, the agent generates a comprehensive implementation plan. This isn't just a list of files, it's a technical blueprint. It breaks down the task into the RTL module, counter 4-bit dum, and its corresponding test bench, tbcounter.v. It specifies the input-output ports, internal logic like synchronous resets, and the stimulus required for verification. This planning phase allows the user to review the architectural approach, ensuring alignment with requirements before execution begins. With the plan approved, the agent moves to execution. It doesn't copy-paste from a database, it generates custom code in real time. Watch as it constructs the counter 4-bit module, correctly implementing the sensitive list always, or arwarm posedge CLK, and the non-blocking assignments essential for sequential logic. Simultaneously, it generates a self-checking test bench. This isn't a stub, it includes clock generation, reset sequences, and assertions to validate the counter's behavior automatically. Now for the critical step, autonomous verification. The agent triggers the customized simulation handler. It compiles the design using Icarus Verilog and immediately runs the simulation. You don't need to remember complex compiler flags or directives. The agent handles the entire toolchain. It monitors the output for success criteria, ready to catch any syntax errors or logic bugs. In this case, we see a clean compilation and a successful test run, confirmed by the tests passed output in the terminal. Finally, we visually confirm the hardware behavior. The agent automatically generated a value change dump.vcd file during simulation. Opening this in GTKWave, we can inspect the signal timing with nanosecond precision. Here we see the clock toggling, the reset signal asserting high, and the counter incrementing from 0 to 15 as expected. This visual proof completes the workflow, giving the user total confidence in the generated design.